Assalamualaikum warahmatullahi wabarakatuh to Season. My name is Muhammad Adika Khairin bin Nur Hisham. I am from DME43 Alpha. My alam ID is 018865. For the final year project 3D modeling, I choose water control valve. And this is the last assembly, and this is water control valve would look like. It consists of inlet housing, thermostat flange, lock lever, handler, and ball valve. And I want you to know that for this measurement, I use in inch instead of millimeter. I use millimeter only in drawing only. Okay, this is for the first part, and the black one is my sketch. First, I draw it like this, and the dimension for this is 2.125 inch. I draw, and this is 0.88 inch and 45 degree here, and I draw one line under this. The thickness is 0.06 inch, and horizontal line, and there is an angle here is 12 degree, and vertical line, horizontal, vertical, and this is 45 degree line here, vertical and horizontal again. And the length for the total here is 2 inch. The thickness from here to here is 0.65 inch. And then I revolve it, so it become like this. It become like this. And what I need to do now is sketch another here. Okay, this is my sketch. The circle is 0.53 inch diameter. From here to here is 1.57 diameter, the outer circle here. From the circle, this small circle, to the center, the distance is 1.575 inch. All the four lines here is 45 degree, and when I sketch, I extrude it to become like this. And then so now we need to make hole at the other side of the inlet housing. So I just mirroring the same hole at the back of the inlet housing, and this is my sketch with the different diameter, which is 0.75 inch diameter, and I cut extrude it, so now it become like this. So chamfer, I chamfer the hole, 4 hole here, 4 hole here, and the inside and outside of the inlet housing. The feature is 0.032 inch with 45 degree. And now for the second chamfer, the big hole at the middle. The feature is 0.125 inch here, only one face with 45 degree. And the last one is fillet. The location of the fillet is at the middle of the cylinder, here and here. It's 0.06 inch. Okay, now for the second part. In second part, instead of I sketch the new part, I just use the first part as the reference for the second part. And first, at here I sketch, I convert entities, and the measurement is same as the here, and I extrude it about 0.65 inch thick. And after I extruding it, I revolve it to be here, and this is the sketch. At here, this is the line here and here is connected. This is the total length of this is 2.75 inch, and the vertical line here and the thickness for here is 0.62 inch. The angle line, the angle between the here to the center line is 15 degree. And as you can see here, there is an arc with the radius 2 inch. So I revolve it and it become here like this, and for next I extrude this circle, and my sketch is quite simple because I just convert entities from this inlet housing, and the whole all together are same size. And now we can see that these two parts are merged together. And what I do next, I delete the body, all the body from the part 1. Okay, and it looks more tinier now. And I want to draw something at the top plane here. So at the plane 1 here, I sketch at here to sketch flange. So the flange here, the smaller circle is 0.38 diameter, and here is 1 inch diameter, and the bigger one here also 1 inch diameter, and the distance between this center of circle and the center of circle, it's about 1.32 inch. And this is the center line, and for this arc here is 0.95 inch, also same with this, and all of this line is tangent with each other. After sketching it, I extrude it to become like this, only, with the thickness 0.388 inch. I merge result it. Now I want to create a cylinder that connected with the inlet housing main body, and this is the sketch. The bigger diameter is 1.5 diameter inch, and I extruded it only up to the surface. Which surface? This surface. So as you can see, the extruded only become like this because they choose the option up to surface. So once it touch the surface, it stop extruded. After that, I chamfer it. I chamfer this hole, 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 the small hole here at the flange, with the future is 0.032 inch, 45 degree, same as the first part here. And then I chamfer the main hole here, 0.125 inch, 45 degree. And lastly, the inner here, the feature is 0.08 inch, 45 degree. Okay, so for the third part, I want to draw the thermostat flange. So we all know that the thermostat flange, the measurement is the same with here. So once again, instead of I sketch the new drawing, I just use from the second part. So from the second part here, I just convert entities here because the measurement is the same with this flange here, and I extruded it. The features is 0.53 inch thick. So after that, I delete the body because I only wanted this flange here only, and I chamfer it all the hole here. The features is 0.032 inch, 45 degree. The phase 1, phase 2 and phase 3. So part 4, what I'm trying to do now is the gate ball valve here, and I draw the vertical line. The length is 5.42 inch, and here the thickness here is 0.5 inch, and this length here is 3.55 inch, and there's a circle here with the radius 1 inch. So after that, I revolve it with the axis of revolution is here, the longest one here. So now I want to make a hole here, and I draw with the diameter is 1.5 inch. I make it coincident so it doesn't move. So I extruded it through all surface of the sphere here. And after doing that, I want to cut here the rectangular shape. This is the sketch. The rectangular, the length is 0.57 inch, the width is 0.18 inch. So now I want to apply this cut extruded within 4 surface here, 4 times. It means 4 times here, here, at the right, and left, and under here. So to do that, there is a features called circular pattern. So 360 degree equal spacing between these 4 shapes, and I want number of instance is 4. The features I want to copy is the cut extrude that we extruded just now, and now it become like this. So now all the 4 sides have been extruded. Okay, now for the fifth part, I want to draw the lock lever. The lock lever act as the lock, so the handler is connected with the handler. Okay, first I draw the circle here with 1.6 inch diameter, and there is line here, and an arc with 1.75 inch radius. So I use center circle, center rectangle here. Square, I'm sorry. The length is 0.83 inch, equal with the 4 sides. So at here is the circle, and the circle, the center, the distance between the center here and the center of the rectangle is about 0.9 inch, and the length from the center to the bottom of the rectangle, the square, is 0.83 inch, while the radius is only 0.17 inch. So after sketching it, I extrude it, so I don't want this circle and this square, and it become like this. So after that, I use fillet features to fillet the 4 sides here. The features, there are 4 edges here, and here, 0.1 inch, symmetric. So after that, I fillet again, this time inside the square. H1, H2, H3, and H4, 0.04 inch symmetrical. Last but not least, I use chamfer for this circle here, 0.02 inch, 45 degree. Okay, now for the second bolt, this bolt is different because this bolt is connected with the thermostat flange. So the sketch is here. The length is 1.625 inch. This length here is 0.38 inch with the thickness 0.09 inch. So I revolve it with this length here act as axis of revolution, 360 degree, and I want to extrude it at the middle of this here. I want to it become like this, so I sketch a hexagon, equal spacing, and the inner diameter is 0.31 inch, from the center of the circle here. So I extrude it with the thickness of 0.25 inch, and now I want to chamfer. Where is the chamfer is these two side here, H1 and H2, 0.038 inch, 45 degree angle. So now the seventh part is I want to draw the nut for here. First, I draw the longest line here is 1.61 inch, and the horizontal here, and vertical again, the thickness is 0.37 inch, and the line here 0.13 inch. So after drawing it and fully defined, I revolve it. The axis is here, revolve 360, so it become like this. So now what I want to do now is to extruded cut here, and 0.42 inch the rectangular, the length, the width is 0.2 inch. I want cut extrude it, and once again the features only apply to up to surface. So once it touch the surface, it stop extruded. So what happened if I do through all? So it just extruded all the way down here until the base of this nut. So now I want to copy it. I want to do it six side. So instead of do it again, I just circular pattern, equal spacing. Which direction I want to copy is the just now 360-degree, six sides, and the features I want to copy is cut extrude. So now it become a perfect hexagon here. Next, I want to cut it a little, with the thickness is 0.06 inch, and make an angle here to, so it become like this. There you can see. And I chamfer the bottom here, 0.058 inch, 45 degree. Okay, now for the last part here, sketch part 8 for the handle. So the handle, the total length for the handle is 8.85 inch. The thickness is 0.18 inch here. The angle is 2 degree only. And here I use two arcs here. As you can see, there are four arcs. 1, 2, 3, and 4. So this arc is 2 inch radius, and for this arc here is 1.13 inch, and this arc here is 2 inch, same, and the last arc here is 1.13 inch. So the length here and here is the same for the radius, and here is the same with here. So 45 degree from this angle to this angle, and also same from this angle to the this horizontal line here. So the thickness for here is 0.44 inch, and the distance from the bottom here, bottom of the handle, and the top of the handle is 1.5 inch, and the distance here from the before the arc here is 1.25 inch, while from here to here for this two radius arc is 1 inch only. So after that, I want to cut extrude uh, the this one I want to cut extruded it. So the sketch is the same. I just convert the entities. So through all, and it become like this. So after that, I use fillet features for the at the end. I use items to fillet. I use three side, one here, two and three. So it become like the half circle here. After that, I want to make the handle with the sphere shape. So I just draw a semicircle here, 1.7 inch radius and diameter, and the axis of revolution is here. So now it become like a small ball, as you can see. And now from this ball, I want to cut it. So I just draw two identical rectangle, and here I draw the center point. So I just mirror it because both of the rectangular is same size. So 0.8 inch same, and this length it is and this length here is 1.46 inch. So I cut extruded it through all. So now so this is the more clearer image. So now after I cut it, now it become like this. It look like a cheese lah. Now what I wanted to do now is I want to make a hole. So I want to make a rectangular hole um, from there like that through all. So first of all I sketch. So it is square, 0.825 inch equal four sides. So I cut it through all. So now it become like this. And once again I post extrude because I want to make a small circle here. So the radius is 0.15 diameter inch, and the circle, the distance between the center to the center of square is 0.9 inch, and the length from the center of the circle to the center of rectangle square is 0.38 inch. So now I boast it 0.4 inch blind. So now it become like this, as you can see. Now I chamfer the outer of the cylinder, the 0.02 inch 45 degree, and after that I fillet. Okay, the fillet is to make it short. I fillet all this handle here, the outer side of the angle of this handle. Okay, H1, H2 and H3, 0.05 inch, and that I fillet again, this time for inside of this square, H1, H2, H3, H4. 0.04 inch, and fillet for this inside of the circle that touch the surface of the handle, 0.04 inch, and for this one and this one also. And last but not least, I chamfer the rectangle hole here, 0.03 inch and 45 degree. Okay, now I have shown you all the egg parts, and now we want to assemble it. So we start it from scratch, new assembly. Okay, and first I want to all of this part. Okay, part 1, part 2, part 3, part 4, part 5, part 6, part 7, and part 8. Okay, so this is part 1, and this is part 2, and this is part 3, part 4, part 5, the lock lever, part 6, the bolt, and part 7. So you can see there is a difference between these two bolts. And last but not least is the valve, the handler of the valve. Okay, so now let's start from the start, from the beginning. So I want to make it. So it's made. I want this to be the same. Okay, coincidence. Okay, and click right. So now I want to align these two hole here because I want to insert nut. So this made again, and this one. Okay, so it already matched, and to make sure is I and, to make sure again, so this one and this one. Okay, so it has. Okay, now I want to insert the. Okay, now I want to insert this nut to this hole. So I choose the surface here and here. Okay, so now it is coincident. Okay, right. Now I want to insert it. I choose this surface here and the surface here, and it become coincident. Okay, so now there is a new feature that I just recently discovered. It is about copy main. So I want to copy with main here, and I want to insert it with this 4 hole here. Click right and repeat. Repeat is here. Okay, 1, 2. Okay, it become like this. Okay, now again, 1, 2, and the last one, 1, 2. Okay, so okay, now we are done for the first. So as you can see, it's quite simple. So now I want to place this thermostat flange here. First we place it at upper of the flange. We select mate. We want to align it with this. Sorry. We want to align it this with this. Okay, it already aligned. And this surface here I want to consider so it don't move. Okay, nice. Okay, as you can see, okay, right. Now we want to insert bolt here. Okay, now for the second bolt that connected with the thermostat flange. So as you can see, there is one bolt here. So I choose mate and I choose this and this body. So it is now concentrate. Okay, done. And now I want it insert it. So I choose this thermostat flange surface and I choose this surface. So now the bolt is inserted inside the thermostat flange. Okay, okay. And now we just copy mates. We right click, copy mates, and choose component we want to make, run, and choose repeat here and here. Okay. Now, I'm sorry. Copy this mate first. Okay, then we choose here and here. Okay, now we want to insert this buff, Colgate buff. So we choose mate, we choose this body and this body. Okay, concentrate. So we upside down here. Okay, I choose this body here and this body to become tangent. Okay, now it okay, now as you can see, yeah, it become like this. Okay, so now I want to insert here this to this. So first I choose mate, I choose this side and this side. So it become like this. Coincidence. Okay. And now next I want to concentrate. I choose this surface and this load level and it become like this. So I choose again this and this. Fix. Okay, now fix. So as you can see, it can move freely. Let me put it in isometric. Okay, as you can see, it can move freely. So now the last one is the handle here. So the handle, once again, we choose mate, choose here and here. Okay, and I want this hole here. And this hole and this body. Okay, now let's coincidence it. So I choose this lock level and this. Okay, like this. So now we are done. Let me put it in isometry. As you can see, this is the buff. It can move for the click animation. So this is it. It close is open, close and open. So that's it. We have done my project, which is water intake valve, and I also has done the exploded view. I made separate video about it. So before I end my video, I would like to thank Sir Hizan for teaching us this subject, because I think um, 3D modeling is important in this industry, because nowadays we use computer to design something. We use AutoCAD, for example, SolidWorks, like we learn computer aided design. So with this basic, I hope I can improve my knowledge in this SolidWorks, so I can advance my career. Maybe after I retired from become a seafarer, I would like to become a designer engineer. So that's all from me, and thanks again, Sir Hizan, for teaching us.